In this lecture, you'll learn how the OSPF, DR, and BDR designated routers work with a lab demo. You can see the lab topology diagram here. So I've got my 4 routers, R6, R7, R8, and R9. They've each been configured with a loopback interface. So R6 has got 192.168.0.6/32. R7 is 192.168.0.7/32. R8 is .8 and R9 is .9. And they're all connected to the Ethernet segment in the middle here. That's on the 172.16.0.0/24 network. Again, R6 is .6, R7 .7, R8 is .8, and R9 is .9. Now, right now, OSPF has been configured on the routers, but there's only a network statement for their loopback interfaces. So OSPF has not been enabled on these Ethernet interfaces yet. So what I'm going to do in the lab is, first off, I'll just verify that everything is set up as expected. And then I'm going to enable OSPF on the Ethernet interfaces. And at that time, because it is a multi-axis segment, a DR and a BDR will be elected. So my question for you now is, which router will be elected as the DR and which router will be elected as the BDR? If you need a few seconds to think about it, then pause the video now because I'm about to tell you the answer. Okay, so the answer is that R9 will be elected as the DR and R8 will be elected as the BDR. I didn't say anything about configuring an OSPF priority, so all 4 routers will have the default priority of 1, and it's the router which has the highest router ID which will be elected as the DR. On the routers here, they've got loopback interfaces, so it will be the loopback address which is used as the router ID. So R9 has got 192.168.0.9, that's the highest address. The second highest is R8 with .8, and then we've got our R7 and R6. So R9 is going to be elected as the DR, and R8 is going to be elected as the BDR. Okay, so let's go and do that and verify that first. Then I will manipulate the DR election and make sure that it ends up being R6, which is the DR, by giving it a higher priority. And we'll also see failover working as well to the BDR when I shut down the DR. Okay, so let's do that now. So I will go on to R6. And on here, let's check the interfaces are there. So I'll do a show IP interface brief. And there you can see it's got the loopback, 192.168.0.6, and the interface connected to the Ethernet segment, 172.16.0.6. I'm not going to show you for every router. You can take my word for it. They've all been configured like that. Okay, let's also check the OSPF configuration. So I will do a show run and pipe that to section OSPF. And you can see that OSPF has been globally enabled on the router, and it's got a network statement for 192.168.0.0, which is the loopback interface. So right now, OSPF has not been enabled on the fast Ethernet interface because I don't have a matching network statement for 172.16.0. And if I do a show IP protocols, I can verify there as well that OSPF is running, and I can see that the router ID is the router's loopback interface. Okay, so everything is set up as I expected. Let's now go and enable OSPF on that Ethernet interface and see what happens. So I will go to global configuration, if I can type it, with a config T, and then router OSPF 1. And over in my other window here, I've got the network statement already typed up to save me typing that in. So I'm going to paste that in. So that's for the Ethernet interface, and that will enable OSPF there. The router knows it's an Ethernet interface, so it knows that a DR needs to be elected. So that is on R6. I also need to do it on R7. So enable prompt, config T, router OSPF 1. And I can use the same network statement again because we're all in the same IP subnet. so that will work just fine. So that's R6 and R7 done. Next up, R8. Do the same thing on there and paste in the network statement. And then I've just got one more to do, which is R9. So I've got the enable prompt, config T again, try not to make the same typo again, router OSPF 1, and paste in the network statement. Okay, so now if I give it a second to converge and form the adjacencies, I should be able to do a show IP OSPF neighbor and see the neighbors. And I'm on R9 right now, and I can see that yes, it has formed adjacencies with .6, .7, and .8. I can see that right now they're showing as all two-way DR other. That's because it is not completed going through the exchange and the loading states and getting to the full state yet. So now I've given it a few more seconds. Let's try that command again. And it is still two-way and DR other. And there we go. Now I can see that the OSPF loading has gone to full. So now if I do that show IP at OSPF neighbor, so you saw earlier they were in the two-way state with all of the neighbors, and now it has completed the loading. And this is on R9. So I know already we checked this earlier, we're expecting R9 to be the DR and R8 to be the BDR, and I can see that. So this is a designated router, so it is going to have a full relationship with all other routers on the segment, and I can see that they are all full. And I can see that R8, I was expecting to be the BDR, and yes, I can see that it is the BDR. R6 and R7 are not designated routers, so they show up as DR for designated router, other, meaning they're not the DR and they are not the BDR. Okay, so that was with the show IP OSPF neighbor command. I can see all that information. I can also do, so from any router now, obviously, if you are troubleshooting this kind of thing in a real-world network and you're looking at a segment which does have multiple routers on there, you're not going to be able to tell at a glance which one has got the highest router ID, which one is going to be the DR. So a really easy way you can find out that information from any router on the segment is by saying show IP OSPF interface, and I can just hit enter there, or I can get more granular and actually enter the interface. So this was on fast Ethernet 0/0. I can do this on any router on that segment, and I can see there that the designated router, the DR, is 192.168.0.9, which is R9, and I can see that the BDR is 192.168.0.8. Okay, so that's the expected output on the DR. Let's have a look now on R8, which is the BDR. And I will do a show IP OSPF neighbors on there too. And I can see that .9 is the DR and .6 and .7 are DR others. And again, both the DR and the BDR do form full state relationship with all the other OSPF routers on there. Let's have a look at one of the DR others now. So I'll go into R7 and I'll do the same command there. Show IP OSPF neighbor, and there I can see it's gone full with the DR at .9, full with the BDR at .8, and .6, which is another DR other, it is just two-way there. So you can see the routers which are not the DR or the BDR with each other, they just go to a two-way relationship. They don't directly exchange routes with each other. Okay, so that was all of the expected behavior. Now, let's force one of the other routers to become the DR. So I can do that on R7. So on R7 here, I'm going to go to global configuration and then interface fast Ethernet 0/0, and I will say IP OSPF priority is going to be 100. Okay, and I'll do an end. Now, it's not going to become the DR yet it's going to wait until the election is forced again. And a way I can do that is by restarting OSPF or by shutting down and bringing up the interface again. So let's just verify that it's still not the DR. So on here, I will do a show IP OSPF interface. And I'll do that for fast 0/0. And I can see there that the designated router is still 192.168.0.9 and the BDR is still .8. But I can see now that on this router, the priority has changed to 100. It was 1 before. So on here, if I do a clear IP OSPF process, this will restart OSPF. I'll say yes to that. It's asking me to verify because this is going to be disruptive. The router is going to drop all its OSPF relationships and it's going to lose its OSPF routes while this happens. We have to wait for it to go back to loading full again. Okay, and that looks like it's done it with the other 3 routers. So now let's do a show IP OSPF interface again. And now I can see that the designated router has changed here. It is 192.168.0.7. The BDR stays the same. It is still 192.168.0.8. Okay, so R9 does not become the BDR. I've just made this one the DR. The BDR is going to remain the same unless something changes there. If I went and rebooted all of my routers now, then what would happen would be that R7 would be the DR and then R9 would be the BDR. But it's not going to cause a disruptive change to change the BDR from R8 to R9 right now. Okay, so that is how you can force one of your routers to become the BDR. Now let's see what happens if the DR goes down. So what I'll do is on my R7 here, I'm able to do this easily because I'm in Packet Tracer. I will just power off the router. So I've just powered off the DR. So now let's see what's happening on my other routers. So let's go on to R8, which was the BDR, and see if it's detected the change yet. Let's do a show IP OSPF interface for fast 0/0. And looking in here, it still sees the designated router as 192.168.0.7. And now I can see, okay, it has just gone down. So if I put that command in again now, then hopefully, yep, I can see that the BDR has now transitioned to the DR because it saw that the DR went down. And the next best router at this point in time is going to be R9. So I can see that it transitions to the BDR. Thanks for watching. If you want to get hands-on practice with Cisco networks for free, then you can download my 400-page CCNA Lab Guide, which you can see above my head right now. Also, check out the video about my CCNA course. It's the highest rated course online. Thanks.